Suppose that 2 by 2 matrix C is 0, -2, -2, and 4. Matrix D is of the same dimension, and has the elements 2, 1, 5, and 2. Let's say that one needs to find the determinant of X, if the matrix equation 2C times D times X minus C squared equals to 0 is given. To begin with, let's take the matrix equation given in the task. The first thing we are going to do is to get the variable x by itself on the left-hand side of the equation. For this purpose, let's add the c squared to both sides of the equation, which results in. Now, to get rid of 2c times d in the left-hand side of the equation, we multiply both sides, on the left, by the inverse of 2c times d. Now, let's look on the expression on the left-hand side. We have the expression that complies with the known formula. A matrix times its inverse, or vice versa, yields the identity matrix. Taking this into consideration, on the left hand of equation, we get the identity matrix times X. Recall that the identity matrix is kind of like the number 1 in the matrix form. Therefore, after these rearrangements, we obtain the equation such as. We are still only halfway to finishing the task. In order to proceed, let's focus more on the 2c times d inverse. One way to continue solving this equation is to multiply matrix C by D, then to invert the obtained matrix. We will perform slightly differently. Recall some properties of inverse matrix. First, the inverse of matrix multiplied by a non-zero scalar can be rewritten as 1 over scalar times the inverse of matrix. Next, if we take the inverse of matrix product, then the result will be the inverse of each matrix multiplied, but we have to change the order. Let's apply these properties to our equation. We get. In the equation, the scalar 1 over 2 is the result of the application of the first property, while the product of D inverse and C inverse refers to the second property. Having in mind that matrix squared is just the matrix multiplied with itself, we rewrite the equation in the form. To continue, the highlighted product of matrix inverse and matrix itself will give us the identity matrix, which finally results in the equation. As you can see, the matrix X is going to be 1 over 2 times D inverse times C. So far, we rearranged the expression with the aim to minimize the calculations that should be done thereafter. In that spirit, all we need to do is perform operations on matrices D and C according to the equation we got. And matrices C and D are such as that were given in the task. In order to get the matrix D inverse, we need the value of determinant, and the adjugate of the matrix. So, the determinant of D is 2 times 2, minus 1 times 5. The 2 by 2 adjugate is obtained by swapping the two elements on the main diagonal, and then, the remaining elements are just rewritten as negative of them. So, we have the result. All the rest, basically are technical things to do, and we go through the interim results. The product of D inverse and C is 2 by 2 matrix, that has the elements -2, 8, 4, and -18. Finally, the scalar multiplication is performed on each element of the matrix. In particular, we were asked to find the determinant of matrix X. Now it becomes easy. Here we are, the final result.